Once you have downloaded the FCSalyzer, if you unzip it, you will find the following files within the folder. These two files are provided to you for analysis, but you will be able to see the following jar files. That means you have to install Java in your PC. Between FCSalyzer and FCSalyzer alternative, I find the alternative jar file to be better. So once you double click on it, you will see this window. We can open it up a bit more, and you can increase the document size to 2 page width so that there's more area to work with. These are some of the buttons that you will need to work with: region, dot plot, density plot, and histogram. So let's start with dot plot. Click on the dot plot button and then create a rectangle. Once you've done that, they will ask you to open up the FCS file. So FCS file will be 001 because this is the calibration one. This FCS file contains information, events from a 2 micron calibration bead and a 3 micron calibration beads. So this is FCS forward scatter that shows the difference in the size. SSC side scatter shows the internal content of the beads, usually related to color, either autofluorescence or from stains. Next, we have to create regions for the different components of interest. We have one RO here, R0. Let's do one for the 3 micron bead also. Okay, so once you've done that, you can go to data files to edit the regions of the gates. Okay, so let's add a gate. We will name it 2 micron, and we will, in strategy, we will link it to the R0 region and press enter, and then we add another gate. This time we color it as blue and link it as 3 micron, name it as 3 micron, and link it to the R1 region and press enter. So now you can see we have already used different colors for the different gates. One for 2 micron beads, one for 3 micron beads. Okay, so let's look at a sample file. We'll do the same thing by clicking on the dot plot and then making a rectangular shape and open up the FCS13 file. We can see the gated region for 2 micron and 3 micron beads are here. So from here, although this is a sample file from marine waters, you can see there's a lot of noise, but you know essentially that the region here is between 2 to 3 micron, and the region here is less than 2 micron. So now let's look at the microorganisms of interest. For flow cytometry, we will focus on Cyanobacteria and Prochlorococcus in this practical. So for Synechococcus, we will use the filter VO Green A. Okay, that will give us the filter for the color that is contained in Synechococcus. Synechococcus, the size is from 0.8 micron to 1.5 micron. So this is 2 micron, so it's somewhere from here to around here. So to gauge it, we use this region. This is 2 micron, so this is from 1.5 to 0.8. So this will be the region for R2 Synechococcus. We will use green. Synecho, and link it to the region R2. Okay, so we have the region for Synechococcus or Cyanobacteria here. Next, for Prochlorococcus, we will change the filter to APC VO770A. So these filters all have different cater for specific wavelengths. So you have to compare with the wavelengths suitable for the autofluorescence of the microorganism that you're interested in. So for here, we will use APC VO 3370A. So the size range for Prochlorococcus is about 0.5 to 0.8 micron. So we'll just click on region. It's smaller than Synechococcus. So here. Okay. So for the Prochlorococcus region, we'll add a gate. We'll give it a yellow color and label it and link it to the region R3. Okay, so now you have all the microorganisms of interest. You have already gated them. This is for Prochlorococcus. This is for Synechococcus, and these are the beads. The red and the blue will be somewhere here. Okay, so if you use the side scatter, okay, you can see here a lot of Cyanobacteria. You can't see the Prochlorococcus clearly, but somewhere here, and here are their beads. So to obtain the counts or events, you have to click on plot and look at the statistics, gate statistics and gate, and that will give you the events for Synechococcus, Prochlorococcus. So naturally the number of Prochlorococcus in the oceans are significantly less than Synechococcus. To increase the confidence in your analysis, it is better if you have a 3 micron, 2 micron and even a 1 micron size calibration beads. That will give you more confidence on how to gate the specific region. And also for Synechococcus, since we are also able to view them under epifluorescence microscope, usually we will calibrate through correlation analysis the counts from both flow cytometry and direct count to see whether we were able to obtain a certain level of precision. Okay. The good thing about having a software like this is any additional file that you open will have all this automatically gated, so you will be able to know the counts, events for Synechococcus and Prochlorococcus immediately. So that will help in the enumeration of these microbes in the sea. It is definitely faster than epifluorescence direct counting. Thank you.